Have you ever wondered why aviation regulators rewrote the rules on aircraft vibration in 1964? And why those rules specifically mention the angle of a propeller, or why a turboprop built in 1958 is still flying over Canadian wildfires today, decades after the airliner it came from was pushed out of the passenger market? Or how an airframe that lost its manufacturer $53 million became the P-3 Orion, a military aircraft that stayed in frontline service for more than half a century. In this video, I will tell you why American Airlines had to send teams of engineers across the country in 1960 and sell $6.50 sightseeing flights just to get the public back onto one of its own airliners, what whirl mode is, and how it could tear a wing off a healthy-looking aircraft in 30 to 40 seconds, with the crew powerless to stop it. Why the Federal Aviation Agency cut this aircraft's cruising speed, ordered every autopilot in the fleet switched off, and still refused to ground it, while the government's own crash investigators quietly declined to fly home on one. And how a single hard landing at Chicago Midway killed 63 people over Indiana a few hours later. This is the story of the Lockheed L-188 Electra. In September of 1959, Braniff Airways took delivery of a new Electra, a $2.3 million turboprop with 132 hours on the airframe. 9 days later, it left Houston on a routine leg to Dallas, climbing toward 9,000 feet. Over Buffalo, Texas, the left wing separated from the aircraft. It broke away about a foot from the fuselage and came down more than a mile from the rest of the wreckage. All 34 people aboard were killed, and for the next 6 months, investigators from the Civil Aeronautics Board could not determine why. The Electra lost a wing in flight twice, 2 aircraft, 6 months apart. That is the entire record of a failure that nearly ended Lockheed's airliner business and exposed a flaw the industry had never thought to look for. This was Lockheed's most important commercial product, the first large turboprop airliner built in the United States, powered by 4 Allison engines derived from those on the C-130 Hercules. It flew about 100 miles per hour faster than any piston airliner in service and cut journey times by roughly 20%. By the time the prototype flew from Burbank in December of 1957, 2 months ahead of schedule, Lockheed held well over 100 orders. When American Airlines began flying it between New York and Chicago, 80% of the seats sold, around 20 points better than its piston flights. The Braniff investigation went nowhere. The board confirmed the wing had come off in flight, but could not say what caused it. According to Robert Serling's account in The Electra Story, investigators were running out of ideas and preparing to close the case without naming a probable cause. 9 days after their final hearings ended, on March 17, 1960, Northwest Orient Flight 710 left Chicago Midway for Miami with 57 passengers and 6 crew. At 18,000 feet, it hit clear air turbulence. The entire right wing separated, along with part of the left. What remained struck the ground near Tell City, Indiana, nose first at close to 90 degrees and at least 600 miles per hour. There were no survivors. 3 days later, the Federal Aviation Agency cut the Electra's maximum airspeed to 275 knots, down from a normal cruise of 360. Administrator Elwood Quesada called it a safety precaution. It was the first major restriction Washington had placed on an aircraft model since 1948. The Electra was not grounded. The agency then convened a closed meeting of about 60 people. The FAA, the Civil Aeronautics Board, NASA, Lockheed, the engine manufacturer, and a senior executive from every domestic airline flying the type. The doors were locked, no minutes were taken, and no reporters were admitted. Inside, Donald Nerup of Northwest Airlines announced he was voluntarily grounding his Electra fleet and said he had already asked Lockheed to return the Boeing Stratocruisers he had traded in to buy them. The other executives talked him out of it. Their argument in Serling's account was that if Northwest grounded its aircraft, public pressure would force everyone else to do the same. Days later, the FAA cut the speed limit again to 225 knots, ordered every autopilot in the fleet disabled, and made wing inspections mandatory after any turbulence encounter or hard landing. The aircraft kept carrying passengers under those conditions. On April 13th, the Civil Aeronautics Board voted unanimously to recommend grounding the entire fleet, roughly 135 aircraft in passenger service. Quesada rejected the recommendation. The board's own investigators working the wreckage at Tell City had refused to fly home on an Electra. Senator Vance Hartke of Indiana made the confidential recommendation public, saying he was shocked that General Quesada would take the chance of ignoring this advice. Lockheed's chairman, Robert Gross, backed the administrator, stating the aircraft was fully airworthy. Anti-Electra jokes spread across the country, among them a fictitious book title, Look Ma, No Wings. Lockheed meanwhile put 250 engineers and $2.5 million into an 8-week effort to find the cause. The company flew an instrumented Electra deliberately into severe turbulence over a California mountain range. It took a complete wing off the assembly line and shook it until it broke, to watch how it failed. Rival manufacturers sent their own engineers to help. Then Lockheed built a 1/8 scale model, put it into NASA Langley's transonic dynamics tunnel, and deliberately loosened one of the outboard engine nacelles. Above roughly 300 miles per hour, the model began to wobble, and it would not settle. On May 12, 1960, the company announced the cause. Lockheed called it one of the most profound engineering problems it had faced in 3 decades of building aircraft. The phenomenon was whirl mode. A spinning propeller behaves as a gyroscope. It is highly stable in its plane of rotation, and that stability normally helps damp vibration in the wing. Push it out of that plane through turbulence or a violent maneuver, and it starts to wobble, precessing exactly as a spinning top wobbles when it is knocked. The engine mounts and nacelle are built to absorb that energy and settle the propeller back down, and across thousands of hours of testing, the Electra's nacelles did precisely that. A damaged engine mount cannot absorb it. The wobble continues, and it damages the mount further, which weakens the structure, which amplifies the wobble. Energy begins transferring out of the engine and into the wing, and the wing starts to flutter. As the mount degrades, the flutter accelerates until the wing is oscillating 2 to 3 times per second, and the structure fails. The whole sequence takes 30 to 40 seconds. A crew that understood exactly what was happening could have done almost nothing about it. Speed alone would not do it. Neither would turbulence or a damaged mount on its own. Both conditions had to be present in the same aircraft at the same moment, which is why the fleet flew nearly 80,000 hours before the first wing came off. On the Northwest aircraft, the damage was traced. Passengers who had flown the earlier leg into Chicago described the landing at Midway as unusually hard, and the wreckage showed a clean tension break in one of the outboard engine struts that had happened before the crash. The FAA later noted that reducing power too high above the runway produced a sink rate that caused a harder touchdown. A landing like that could crack an engine mount without leaving a visible sign on an aircraft that flew normally until it met real turbulence. The damage to the Braniff aircraft was never fully explained. A week before the crash, a trainee pilot recovered improperly from a planned stall, and the aircraft went through severe buffeting. The instructor said afterward he did not believe it was severe enough to warrant an inspection. The wreckage showed engine support struts on one outboard engine bent in several directions. The precise cause was never completely determined. The fix cost Lockheed $25 million, redesigned engine mounts, nacelles and cowlings, a strengthened wing, and a redesigned attachment between the engine gearbox and the struts. It added about 1,400 pounds of metal to every aircraft. The work ran out of Burbank, 9 aircraft at a time. The FAA recertified the modified Electra at the end of 1960 and lifted the speed restrictions in January of 1961. The modifications resolved the problem, and the Electra became one of the most reliable and economical aircraft its operators flew. The commercial damage was harder to repair. In the 10 days after the Indiana crash, American Airlines alone recorded nearly 2,300 cancelled reservations, with every customer citing a previous Electra crash as the reason. So the airline sent out what it called truth squads, 5 teams of pilots and engineers who traveled city to city holding press conferences and explaining gyroscopic precession to civic groups. They reached 18 of the 26 cities the aircraft served and sold 30-minute Electra sightseeing flights for $6.50 to get people back on board. It worked. Within a year, Americans' Electra load factors were beating its pure jets, and Western Airlines had climbed from a low of 49% to 62%. The orders never returned. Lockheed built 170 Electras and ended production, losing $53 million on the program as the jets took the market. The same airframe became the P-3 Orion, which stayed in frontline military service for more than 50 years and sold in the hundreds. A handful of Electras still fly in Canada as water bombers and freighters with air spray and Buffalo Airways. The oldest one in Airspray's fleet was built in 1958. In 1964, the FAA rewrote its design rules on flutter and vibration. Aircraft would now have to account for the effects of a change in propeller angle and for what the failure of one structural component does to the vibration of everything around it. Those rules exist because of Buffalo, Texas, and Tell City, Indiana. The Electra did not repeatedly shed its wings. It lost them twice, and in each case the aircraft was already damaged in a way no inspection was looking for, that no test had predicted, and that took 30 to 40 seconds to kill everyone on board. 97 people found the flaw. The engineers found it 8 months later.